Alright, so number 9 asks us to solve this equation by completing the square as well as using the quadratic formula. So let's start with completing the square. Alright, so since our number in front of the x squared is not a 1, we're going to divide both sides of the equation by that number. So let's divide both sides by 4. Alright, so that's going to leave us with x squared plus, alright, here we have a fraction, 3/4, and then equals 3x. Alright, now from here, we want to move all our x's to one side of the equation. So I'm going to leave the x squared on the left, and I'm going to take this 3x, and when I move it on the same side of the equation as the x squared, it becomes a negative 3x. And then I'm going to take this positive 3/4, and when I move it to the other side of the equation, because remember, I want to get all my numbers over here, it's going to become a negative, so negative 3/4. Alright, now what I like to do is I like to open up two boxes. And to find the number that goes in this box right here, you look at the term before it. So we have a negative 3. So what you're going to do is you're going to take the negative 3 and divide it by 2 and then square it. Okay, so we're going to take negative 3, I'll do that up over here, and divide it by 2 and then square it. Okay, well, a negative times a negative is a positive, and then 3 squared is 9, and 2 squared is 4. So what we're doing is we're adding 9/4 to both sides of the equation. Okay, now if you factor this, we're going to have 2 of the same factors. Now, if you want to find two numbers that multiply to 9/4 and add to negative 3, remember the trick is really just to take half of this number and put it here and here. So half of negative 3 is negative 3/2. And remember, please write these as fractions, not decimals, because when you come to the end, when you have to simplify your radicals, you will need them in fraction form. Okay, now if we combine these, negative 3/4 plus 9/4 is positive 6/4. And I'm just going to simplify that. 6/4 simplifies to 3/2. Okay, so now since we have two of the same factors here, we can take it and write it as x minus 3/2 squared. And then I'll bring down the equals 3/2. Alright, to get rid of a square, we take the square root. So that leaves us with x minus 3/2 equals, and on this side we're going to have positive and negative. Now, when you go to take the square root of a fraction, you could take the square root of the top and the square root of the bottom. Now, if you guys remember from actually last year in geometry, you'll remember you never want to leave a fraction with a radical in the denominator. So in order to get rid of that, what I'm going to do is I'm going to multiply the top and bottom of this by the radical in the denominator. So what that's going to leave us with then is, well, radical 3 times radical 2 is radical 6. And then radical 2 times radical 2 is radical 4. And radical 4 just simplifies to 2. Alright, so at this point we have x minus 3/2 equals positive and negative 6 radical 2. And to finish, all you have to do is just take this negative 3/2 and just add it to both sides of the equation. So when you take a negative 3/2 and move it to the other side of the equation, it becomes positive 3/2. So it leaves us with x equals positive 3/2 plus and minus radical 6 over 2. And if you prefer to make this into one fraction, since it already has a common denominator, you're just going to add the top. So we have 3 plus and minus radical 6, and you can put that whole thing right over 2. Either answer is fine, so I'm just going to write or here. We also have to solve number 9 using the quadratic formula. So with the quadratic formula, you first want to set the equation equal to 0. So if you subtract 12x from both sides, that's going to leave us with 4x squared minus 12x plus 3 equals 0. So if you like to label your a, b, and c, your a is going to be 4, your b is negative 12, and your c is 3. Alright, so let's just plug it right into the quadratic formula. So we're going to have x equals negative 12, so positive 12, plus and minus the square root of negative 12 in parentheses, okay, you need those parentheses there, squared, minus 4 times 3. And that whole thing is going to be over 2 times 4. Alright, so that leaves us with x equals 12 plus and minus the the square root. So now you have to figure out what all this under the radical is equal to, and it's actually equal to 96. And since 2 times 4 is 8, we're going to put that whole thing over 8. All right, so now let's just break up the radical 96. So two numbers that multiply to 96, where one of them is a perfect square, is 16 and 6. So I'm going to break this up into radical 16 and radical 6. And remember, you always put your perfect square radical first, and then whatever's left over under the second radical. All right, so since the square root of 16 is 4, I'm going to just rewrite this as 12 plus and minus 4 radical 6 over 8. And then really all you have to do is just look at these numbers on the outside of the radical, so all these whole numbers, and say, well, what divides evenly to all three of them? Well, 4. So if I do 12 divided by 4, that gives me 3. So as of right now, I have x equals 3 plus and minus. 4 divided by 4 is just 1, so you could write 1 radical 6 or just radical 6. And then 8 divided by 4 is 2, so we could put a 2 down here, and that's it. Okay, so you can stop this and read number 10 on your own if you want, but letter A asks us to find the zeros of this function. So our zeros are, let's see, right here at x equals 0, and then right here at x equals 10. It's just where the graph crosses or touches the x-axis. Okay, letter B wants us to find the relative maximum and the relative minimum. Now, keep in mind, if they said relative maximum value and relative minimum value, we would just be looking for the y values. But because it says relative max and relative min, they're looking for you to write them as coordinates. Okay, so let's see. The relative max is right here. And you can probably see it better on your paper than you can on here. But I estimate that to be at 3,600. And the relative minimum is actually right here. Okay, so this is our maximum, this is our minimum. And the minimum I estimate to be at 10, 0. Okay, letter C gives us this function f of x equals c times x minus 10 squared. And they want us to use this function to solve for c. Now they tell us to specifically use the coordinate 5, 5, 10. So we're going to replace the x's with the 5, and we're going to replace the y with 5, 10. Now remember, another way of saying f of x is y. So we're going to replace the f of x with the 5, 10. The c is what we're solving for, and wherever we see an x, we're going to replace it with a 5. Okay, so this leaves us with 510 equals c times 5 times, well, 5 minus 10 is negative 5, and negative 5 squared is 25. Okay, and then since 5 times 25 is 125, we have 510 equals 125 times c. And to get the c by itself, just divide both sides by 125, and that leaves us with c being equal to 4.08. Okay, in letter D, they want us to use the graph to estimate the volume if the radius is 2 centimeters. So all we have to do is go over to a radius of 2 on the graph and follow it up. And I estimate that to be right here at a height of 500. So I think the volume would be 500. And we're talking about centimeters, and since it's volume, we would say centimeters cubed. Okay, and then finally, I'm just going to box off my answers here. Finally, for part E wants us to use our function to estimate the volume if the radius is 2. So we're going to go back to our function over here from part C. The only difference is now that we know that C is 4.08, let's substitute that with a 4.8. So our function is f of x equals 4.08 times x, and then times x minus 10 squared. So if we're looking for the volume when the radius is 2, we want to substitute an x value of 2. So we're looking for f of 2. All right, so that's going to be 4.08, and replace all these x's with 2's. Okay, now, what you can do is you can really just plug this entire thing into your calculator, and I would do it all at once. I wouldn't do it in steps, because the more steps you take, the more room there is to make mistakes, and remember, the more mistakes you make, the more points you get off on a test. So you want to try to do it in, fewer steps. So when you plug all that into your calculator, you wind up getting 522.24 centimeters cubed. All right, and then it says, how does this value compare to the value you obtained in Part D? Well, I would say these values right here are relatively close, considering we're rounding, especially considering we're rounding to the nearest 50 units on the y-axis. So I would say these are pretty close. Okay, so number 11, the first thing they want you to find is the x-intercepts. Now, remember if they ask for the roots, the zeros, or the solutions, you would just be writing the x values. But here, if you want the x-intercepts, we need to write these as coordinates. So it looks like we have an x-intercept right here, and right here. All right, so I estimate the coordinates of the first one to be about negative 2.60. The next one to be about 0.30, and that last one to be about 3.60. So as long as you have something close to that, your answers are fine. Okay, letter B, they want you to use the x-intercepts to write an equation for f of x. Okay, so letter B, we can write f of x equals. Now, what we're going to do is we're going to use these x values right here in order to create our factors. So if we have an x value of negative 2.6, remember, to make the factor, you would have to change the sign. So we could have x plus 2.6. Okay, the factor that goes along with positive 0.3 would be x minus 0.3. And then the factor that goes along with x equals 3.6 would be x minus 3.6. Now, the reason I left a space in the beginning here is because, remember, you can multiply a function by some constant, and it's not going to change your roots. Okay, it's just going to change really how amplified your function is or how stretched out your function is, but it's not going to change your roots. Okay, now Part C is for the relative extrema. Again, they don't say the word values. If it said values, you would have to write just the y value, but when they want, the relative max and the relative min, they're looking for coordinates. All right, so the relative max looks to be right about here. So I would estimate the coordinates of that to be about negative 2.5 and then positive 2.2. And then the relative min is right about here. So I would estimate that to be, I guess, about positive 2.2 and then negative 2.7. Okay, as long as you're somewhere around there. I mean, who's to say my estimates are better than yours, right? So as long as it's somewhere close, then you're fine. Letter D asks us to use the minimum point to find the leading coefficient, and they want us to round our answer to the nearest 10,000th. Okay, so here's our equation right here. I got that from Part B. We came up with that. And then they want us to plug in the relative minimum. Now, here's our x-coordinate, so I can replace all the x's with 2.2. And negative 2.7 is our y-coordinate. So we can replace the f of x, which just means y equals, with negative 2.7. Okay, so now we can just individually figure out what all these parentheses here are equal to. So I got 4.8 for the first one. The second one gave me 1.9, and the third parenthesis gave me negative 1.4. And then we can just multiply all these together. So when you do, you wind up getting negative 12.768. Now, you could totally just skip this step. You can just plug this whole thing in your calculator and just jump right down here to the negative 12.768. And keep in mind, the less steps you do, the less chance there is for getting points off, right? Because less room for mistakes. So you could jump right from there to there. Okay, so anyway, let's just divide both sides of the equation by negative 12.768. And when we do, to the nearest 10,000th, which is 4 decimal places, I get 0.2115. Now, keep in mind, your answer may not be exact to this because, we had to do lots of rounding, we had to do lots of estimations throughout the problem. So as long as you have something, fairly close, then you're fine. All right, so this last part just wants us to use our function, which we have right here. And remember now, we know the value of c, to calculate f of negative 2. So if we want to calculate f of negative 2, all we're going to do is replace every x we see with a negative 2. All right, now you could just plug this entire thing into your calculator, and they want you to round your answer to the nearest tenth. So I'm getting 1.6. Now it says to use your graph to determine if this is a reasonable answer. So what this is saying is that when x is equal to negative 2, does f of negative 2, does your y value equal 1.6? So let's look at our graph. If we go over to the x-axis to negative 2 and follow it up, yeah, it does appear that the y value on the graph is approximately 1.6. So yeah, you could say this is an appropriate y value.